We are discussing the exercise question of motion in a straight line. So the first question is, in which of the following example of motion can a body be considered approximately a point object? So this question wants to know either we have a clear concept about the point object or not. So when we call the object as a point object, when the distance covered by a specific object is larger than the size of the object itself in a stipulated time, so then the object is known as a point object. Otherwise, if the size and the distance covered by that object is not that much difference, then it is not considered as a point object. We'll consider that object as it is. So it will be cleared from the following example. Considering the first statement, a railway carriage moving without a jerk between two stations. So if this is a situation, this is station A and B. If a railway carriage, this is the size, it's moved between these two stations. So if we compare the distance between these two stations and the size of this rail, then it is smaller in comparison. So we consider this as a point object. Now moving on to the next example. A monkey is sitting on the top of a man cycling smoothly on a circular track. So this is a circular track. A monkey sitting on the top of a man. So the path traveled by the monkey is more in comparison to the size of monkey itself. So in this case also the object is point object. Now moving on to the third case, spinning cricket ball that turns sharply on hitting the ground. So a bowler bowls and then after striking the ground it spins. So if we compare the size of the ball and the distance after the striking the ground it is traveling is not that much. So in this case this ball is not a point object. This is not a point object. Now moving on to the last example, a tumbling beaker that has slipped off the edge of the table. So if this is a case, there is a beaker and tumbling by mistake it is falling on the ground. So if we compare the size of this bottle or beaker in comparison to distance that it is covering, is not that much difference. So even in this case this object is not a point object. This is not a point object. So if we look to the examples, although the size of this thing is much bigger, but in comparison to the distance it is not that much, so this is a point object. But although the size of this ball is smaller, even though it is not considered a point object, because in comparison to the distance that it is traveling in a given time interval. So same is the case with this beaker also, and same is the case with this monkey also. In case of monkey it is a point object as according to the size of the monkey and the distance it is traveling is much larger. Okay, so to move on to the next question. Next question is related with the graph, position time graph. So through this question they want you to know that do you have a clear concept of position time graph. Just consider x-axis they have given the time, y-axis this is the position. There is a situation when the two children A and B, it is A, it is B, are returning from their school O to their homes P and Q. So this is P and Q respectively. Choose the correct entries in the brackets below. So basically they want to know, they will give you the 4-5 situations, then who will reach the home first, or who lives closer to the home, who lives closer to the school, or does they reach their home the same time. This sort of question they're gonna ask you. So we have to explain or answer all these questions just by looking to this graph. So what are the information this graph providing us? So the explanation for this, look, so all of you have understood what is this, what was the situation was just like this. This is position time graph. The two case they have given, this is a graph for A, this is the graph for B, okay, and these are the position P and Q are the situations, okay, and this is the position of a school. So in the first case, in the given distance time graph, it can observe that the distance OP, this length O to P is lesser than OQ, okay. So this OP is less than OQ. Hence the distance of a school from A's home is less than that of B's home. Clear? Then for the second question, from the given graph, it can be observed that for x equal to 0, and when the time is 0, means they are talking about this position, where the x is 0, t has some finite value for b. They are talking about this position. So even the distance is 0 for b, but there is some time out there. Okay, so this is the case for b, and this is the case for a. Thus a start his journey from school earlier than b. Just look to it. So a is starting bit earlier than b. So moving on to the third situation, it can be observed that the slope of b is greater than a. How do you find slope? Slope is the angle that a or b makes with this axis, time axis. So if you look to the graph, if this one is theta 1, if this is theta 2, so obviously this theta 2 is more than theta 1. You can look to the graph and find it by yourself that theta 2 is looking more than theta 1. Which means slope is greater. So the xt graph gives the speed slope of distance time graph. This you can note down. Okay, wherever in the graphical question you have to find the speed, so you can find it by finding the slope of distance time graph. Okay, so the greater the slope means the speed of b is greater than that of a. Okay, so theta 2, that is slope of b is more, that's why b's speed is more than a's. Clear? So to move on to the next one. Now moving on to the last thing, it is clear from the given graph that both A and B reaches their respective home at the same time. Okay, so both of them are reaching at the same time. Why? Bit A is just starting bit earlier, although B is just starting late, but B has more speed than A. So both of them are reaching their homes at the same time. Okay. Now B moves later than A and its speed is greater than that of A. For the graph, it is clear that B overtakes A only once on the road. So this is the point where the B overtakes A. So this is the only point where the B is crossing A, nowhere else, not before, not after. So there is only one position where B overtakes A, while going to home from school. Okay, all clear?